All right, let's get right into it. What we're talking about today isn't just about some safety meeting checklist. This is serious stuff. This is the difference between clocking out and going home and becoming another statistic. So listen up, because this information could literally save your hand, your arm, or even your life. 42 minutes. Every 42 minutes, a worker in the US gets a machine-related amputation or a crush injury. Just think about that for a second. By the time we're done here, it's already happened to somebody. The whole point of this is to make damn sure that person is never, ever you. And it really comes down to this. On one side, you've got a machine with the guard in place. The operator does their job, finishes their shift, goes home safe. On the other side, same machine, guard's been removed. And the result is a catastrophic, life-changing injury. I'm not exaggerating here. This is the reality. This is what's at stake every single day. Now, before we even get to the guards, you have to know what they're protecting you from. You can't guard against a hazard you don't even see coming. These aren't just words on a page. These are the mechanical actions that have literally taken people's fingers, hands, and worse. Let's make sure you can spot them. Okay, here are the big four. First, the point of operation. That's where the work gets done. The cutting, the shaping, the bending. Then you have in-running nip points. That's where two moving parts come together and create a pinch point that can just pull you right in. Next, rotating parts. They can grab a loose sleeve, hair, or jewelry in less than a second. And of course, flying chips and sparks, which can cause serious eye injuries or fires. These are the killers. So, how do we fight back against these hazards? Well, the best way, your absolute first line of defense, is through what we call engineering controls. In other words, the guards themselves. These are not optional extras. They are physical barriers. And they have one job: to keep you away from the danger zone. You're going to see a few different types of guards out on the floor, but these 5 are the most common. You've got your fixed guards, those are the permanent ones. Then you have interlocked guards, which are actually connected to the machine's power. There are also adjustable and self-adjusting guards that move with the material. And finally, barrier guards that basically build a fence around the machine. Pay attention, because we're about to test you on this. And you can see the difference right here. A fixed guard, like this yellow mesh, is for parts of the machine you should never need to get into while it's running. It's bolted shut. But an interlocked guard, like the one on this big drum, is for a spot you do need to access. The second you open it, the power is cut. It's 2 different problems with 2 smart, engineered solutions. If you take away only one thing today, let it be this. The guard has to be in place, and it has to be working every single time that machine is on. Not just most of the time, all of the time. There was no good reason to ever bypass a guard during operation. Not to go faster, not because it's easier, no exceptions. Period. So whose job is it to make sure that guard is there? It's a team effort. Your employer has to provide the right guards and make sure they're maintained. But you, the operator, you are responsible for using them every time and for reporting any issue the second you see it. Safety is an active, shared responsibility. Okay, you've heard the fundamentals. Now it's time to see what you really know. I've got 10 questions here that trip up even veteran operators. The goal is simple. Don't be one of them. You ready? Let's do this. Question number 1. Let's start with the big picture. What is the number 1 absolute main reason we have machine guards? Take 5 seconds. The answer is B, to protect workers. End of story. OSHA's rule 1910.212 is crystal clear. A guard's only job is to protect people. If you picked A for efficiency, you're dead wrong. Safety always comes before speed. If you said C, maintenance access, it's actually the opposite. You usually have to remove them for maintenance, and you do that with Lockout/Tagout. And D, yeah, it might keep some dirt out, but that's just a side benefit, not the reason it exists. Question 2, this is a big one, a key term from OSHA. When we talk about the point of operation, what exactly are we referring to? And the correct answer is B. The point of operation is exactly what it says. It's the point where the machine is actually doing its work on the material. Just think of it as the business end of the equipment. It's not the on-off switch, that's just a control, and it's not the belts and gears, that's the power transmission, a totally separate hazard that needs its own guarding. OSHA focuses on this term because that's where most people get hurt. Question 3. This is a situation that happens all the time. You're behind schedule, the pressure's on, your supervisor walks over and says, "Hey, just pop that guard off for a bit, we need to make up time." Can you do it? True or false? The answer is a hard, unequivocal false. This is a trap, and it's how people lose fingers. Your supervisor's instructions do not, I repeat, do not override federal law. The only time a guard comes off is when that machine is completely de-energized and locked out, for something specific like maintenance. Bypassing a guard for production is always a major violation. Question 4. We talked about those interlocked guards, so what is their number one job? What is the one thing that has to happen the very instant that door or gate is opened? The correct answer is C. The machine's hazardous motion must stop immediately. That guard is physically wired into the machine's power circuit. When you open it, you break that circuit. Sure, an alarm might go off, but that's an extra. The primary safety function is killing the power. Any kind of delay, even just for a second, is way too long. Question 5. Okay, OSHA is pretty clear about what counts as a real guard. Out of these 4 options, which one is not considered an acceptable primary way to guard a machine by itself? The answer is C, an awareness barrier. A painted line on the floor, a little chain, or a sign, that is not a guard. Why? Because it offers zero physical protection. It relies completely on you remembering it's there. A, B, and D are all real engineering controls. They're physical barriers. A painted line might be used as an extra warning, but it can never be the main source of protection. Question number 6. We talked about those bolted-on fixed guards. So when is that the right tool for the job? Think about its design. It's meant to be permanent. So what's the perfect situation for that? The right answer is C, when no access is needed during normal operation. That's the key. Fixed guards are perfect for covering things like drive belts, chains, and gears. You basically set it and forget it. If you picked A, frequent access, that is the exact opposite. That's when you would use an interlocked guard. Okay, question 7. It's the start of your shift. You walk up to your machine. Right then and there, who is the number one person responsible for checking that the guards are in place and working correctly? The answer is C, the machine operator. You. Look, safety is everyone's job, but you are the last line of defense. You're the one about to put your hands near that machine. It is your right and it is your duty to do a quick inspection every single time to make sure those guards are present, secure, and working. Never, ever assume it's safe. You verify it. Question 8. Another scenario we see way too often. An operator takes off the guard on a drill press because he says it's hard to see the workpiece. How would you describe that action? The answer, and it's not even close, is C, a serious OSHA violation that creates an amputation hazard. I need to be really clear about this. If a guard is getting in the way, it might be the wrong kind of guard. The solution is to talk to your supervisor and figure out the right way to fix it, not to just remove the only thing keeping you safe.
Question 9. Let's get a little technical for a second, because knowing where the rules come from is important. Which of these is the main foundational OSHA standard that lays out the general rules for all machine guarding?
The correct answer is C, 1910.212. If you're going to remember just one number from all this, make it that one. It's the cornerstone of machine guarding. Think of it this way. 1910.147 is the lockout tagout rule. That tells you how to work safely when the guard is off. But 1910.212 is the rule that says the guard has to be there in the first place. All right, last question. Let's say you have the best guard possible, but there's still a small hazard, maybe a stray chip that could fly out. In that situation, what's the right thing to do next? And the correct answer is B, use the right PPE. This gets to a super important idea called the hierarchy of controls. Engineering controls, like guards, are always the top priority. If they can't eliminate 100% of the risk, you add things like PPE. Your safety glasses or gloves are there to support the guard, never, ever to replace it. Okay, quiz is over. Now for the real test. Let's put this into practice. You're starting your shift, you walk up to a conveyor line, and you notice right away the guard over the main drive belt is just gone. What do? Every single second matters here. Let's walk through it, step by step. There are 4 steps, and they are not negotiable. First, stop. Don't touch a single button. Don't even think about turning it on. Second, notify. Tell your supervisor immediately. This is an imminent, dangerous situation. Third, secure. You need to make sure nobody else can come along and start that machine. That means applying your lock and your tag. And finally, fourth, verify. After a qualified person puts the guard back on, you personally check it. Make sure it's installed right and it's secure before you even consider starting that machine. No deadline is worth skipping any of these steps. And this quote right here says it all. The physical guard on that machine is always priority number one. All your training, all your procedures, your safety glasses, they are all critical, but they are there to back up the guard, not to take its place. Because at the end of the day, this all comes down to you. It's about your knowledge, your attention to detail, and your courage to speak up when something is wrong. The company gives you the tools, but you're the one on the front line making sure they're used right. It's your responsibility because it's your life. And this is what it's supposed to look like. A strong, properly installed guard, completely separating workers from the rotating parts and the nip points on this conveyor. This is safety by design. This is what lets everyone go home in one piece.
Hey, you made it through. Great job. Whether you aced every question or learned something new, the most important thing is that you never stop learning and never get complacent. Safety is a full-time job. To keep your skills sharp, make sure you subscribe to HSC Study. We've always got more essential training coming your way. Until then, stay vigilant out there and stay safe.